we're taking float measurement on the lower basin stream. This is a really easy, cheap way to measure the average surface velocity. So you're going to need a measuring tape, a timer that goes like the tenths of a second, say 17.10 seconds sort of measurement, a net, and the net is going to be catching like a ping pong ball, something light that floats. It also helps if you have a meter stick. That way you can measure the depth, because you're going to need to measure that. Although if you find a stick in the field, you can kind of use that and then just measure how much was underwater. Waders are also useful. So the idea is that you're going to time how long it takes the float to go from the start to the end of a measured length of the stream. You want to do at least 3 runs. The more is better, because we're averaging this. So if you can get up to 6 runs, that's great. That's what we were able to do. We're doing lower basin float. The first thing we want to do is measure the length.
And we're just making sure to go parallel to the stream and that our measuring tape is taut all the way through. What's the measurement?
The measurement is 16 feet and 3 inches.
Okay. Yeah. So,
Yeah. Alright, so that is 4.5 feet wide.
now we're taking 3 cross-sectional depths, one at the middle, and then 1 left bank, then 1 right bank. She is going to get in the stream, determine the midpoint of our cross-sectional line, and then stick the branch in there, and then we're going to measure the depth based off of the branch.
Yeah.
3, 3. Just to the top of the rock.
Okay. Yeah. Okay. And
You say 5 inches?
yeah. 5 inches.
So, 275 to 4.5.
Okay.
There we go. And then we'll take one from the midpoint, halfway between the midpoint and this bank.
Alright.
So full top, we're at 1.
So 0.75, yeah.
So let's do that.
Okay. Oh, fairly uniform.
Now we've taken our cross-sectional areas and our lengths, and now we're going to put the measurement tape back down the stretch and start our float test.
Alright.
She's clearing the debris. We chose this site because it's representative of the stream length and relatively clear, so nothing interrupts our float. But we continue to clear it out. Now the stream looks pretty clear, and we can begin our float test.
So now we're measuring the velocity of the stream.
Okay. Here we go. And now.
I started it when it passed the stick.
Awesome.
Okay.
No, don't go to the side.
It's very important to talk to the ball while you take the measurement.
This way. Come on.
Positive encouragement makes for better trial.
Yeah. It's like with plants. They're listening. They're always listening. Dang, there we go.
Little guy.
He's trying his best. There you go.
Stop.
Okay. And we record 37 seconds, 0.7. A foot.
Yeah, I'd say this is about a foot before the starting point, right?
Yeah.
50?
It gets to average.
Yeah, so then gets an average velocity, and it also gives you plenty of time to hit the start and stop. All right, here we go.
Jamie, right
Yes. Just taking a leisurely ride.
What's the time this time?
32.71, so quite a bit quicker than our first trial.
We're doing the third trial now.
Alright. Here we go.
We'll do 2 more trials to make it more accurate.
After collecting your field data, you will return back to the lab to do calculations. We will calculate cross-sectional area of the stream, average surface velocity of the stream, estimate the discharge of the stream, correct the discharge with a coefficient. Finding the cross-sectional area requires depth measurements and the width of your float section. First step is to average your depth measurements and then multiply it by your width. This will give you your cross-sectional area. Finding average surface velocity requires float times and the length of a float section. Begin by averaging your float times. Then divide your section length by the average float time. This is your surface velocity. Estimating your discharge requires having calculated your average surface velocity and having calculated your cross-sectional area. Multiply your cross-sectional area with average surface velocity to estimate a stream discharge. Your answer will be in units of volume per second. Correcting discharge requires having made stream observations and having calculated your discharge rate. This is important because surface flow is higher than average flow. Usually, lower values for rougher and more shallow beds are used, while higher values are used for smoother beds. This is also applicable for finding subsurface velocity. Applying a correction factor to surface velocity will also let you find subsurface velocity. In this example, we will use a correction factor of 0.8. Multiply your discharge by your correction factor, and you will have a corrected discharge rate. Having finished lab calculations, you will now have a cross-sectional area, a surface velocity, and a corrected discharge. These data will give a better understanding of the stream site.